Dalton's law of partial pressure. Dalton's law states that the pressure of a gas that do not react is a total of the sum of individual pressure of those gases. Mathematically, Dalton's law can be represented as P total is equals to PA plus PB plus PC, and so on till we get to Pn. Let's talk about Gay-Lussac's law. Gay-Lussac's law of combining volume states that the volumes of gases which react are in simple ratio with each other and with the volume of their product if gaseous. What Graham's law is talking about is that the volume of gases on reaction are always in simple ratio. Permit me to explain more to you that if hydrogen and oxygen react to give water, on balancing the chemical equation, we'll find out that 2 volume of hydrogen react with 1 volume of water to produce 1 volume of oxygen to produce 2 volume of steam. What Graham's law is talking about, that the combining volumes of those gases are in simple ratio. So for hydrogen to oxygen combination is 2:1. We are going to be looking at the ideal gas equation. The ideal gas equation stipulates that for ideal gases, PV over T is constant at STP. Pressure, volume, and temperature ratio is constant for an ideal gas, such that PV is always equals to nRT, where N is the number of moles of the gases, T is temperature, P and V are pressure and volume respectively, where R is what we call the ideal gas constant. Finally, in gas law, we are going to be talking about Graham's law of diffusion. Graham's law of diffusion simply states that the rate of diffusion of a gas at constant temperature and pressure is inversely proportional to the square of its density, the square root of its density rather. So by mathematical extrapolation, Graham's law is giving us R1 over R2 is equals to the square root of M2 over M1. It can also be represented as R1 over R2 is equals to the square root of D2 over D1, where M and D are relative molecular masses for the gas and density respectively. As an advice or a tip, especially concerning gas laws, I would love you to go through past questions and attempt as many questions as you can in gas laws. Know the formulas at the fingertip and know how the questions are structured in the exam. Furthermore, I would like us to I will tell you more about liquids, gases, and vapor. Liquids are the intermediate states between solids and gases. They have similar orderliness of solids and the randomness of gases. They are in between. So liquids have a definite volume but no definite shape. They flow and they usually assume the shape of their containers. Furthermore, vapor and gases. A gas is a substance at a distinct state at a particular temperature. For example, oxygen gas. At a particular temperature, room temperature or whatever temperature, oxygen is a gas. Meanwhile, a vapor is a substance at a particular temperature is in 2 phases. It's not solid, it's not gas, neither is it liquid. Vapor is the first state or the first stage by which a substance assumes when it is undergoing evaporation. That is the conversion from liquid phase to gaseous state. That is all concerning gas, liquids, and vapor. In the next video, I'm going to be teaching you more on solids, its properties, types, and we'll take a distinct look at two most common solids that appear in examinations under this module.